Those are just one. Okay. Negative 2.
That's going to be the
2. So this. X minus 2, X. Yeah, X plus 3. Yeah. I don't know why I put X minus 3 on top. I must have been like still asleep. So. Whoops. That's why you check your word. That's my word. And then that's why I always ask you. That's why I was asking. I know. It's always good to prepare. We get into like a repetitive mode and skim through things. Yeah, because especially if you come from math, when I you go into confident. I'm not just what I'm doing. It's funny, I help with the most complicated.
No, I like it.
And you help with the most
I don't like the number 3.
This was like the most complicated one.
I know. I can't believe I came through it that easy.
Number 5 was like,
Always do that.
number 5 was like,
When I think I know something.
number 5 was like number 5 was like the hardest one. It's just that it takes more time.
There's no number 3, is there?
No, it's number 3, that's what I said.
You gotta get one to go. Don't wait, dude. They got this hydro flask.
Oh, I thought you had a small one. How do you carry it?
They had one, but I had coffee pop this, so I don't like the handle one. It's just so
Wait, is this?
and I don't like the straws.
that's the problem.
Yeah, that's right.
I don't like straws.
I'm gonna have to drink some electrolytes. If I drink too much of this and electrolytes, it's a headache.
No, it's okay. I'm not going to interrupt some good conversation. I was trying to figure out what they're saying right there.
I thought there was a 3.
No. 3 has had his day.
Plus minus. Negative 2. X 3 is negative X 2. Negative 2X 6.
All right, guys, let's take a look.
Alrighty.
What's interesting about this first problem is it doesn't even matter there's an X because they both got it, so I don't really care. It's almost like a normal fraction from way back in the day. So they both have an X. Nobody needs it. They both got it. What does this first guy need, though? 7. And this guy needs 2. And now they both have 14x on the bottom. So you get 21 plus 8, so you get 29 over. Can't reduce it, so you're done. Not too bad. Then we get to number 2. Yes?
You wouldn't multiply by y, would you multiply by 7x?
They both already have an x. Yeah, I like it. You could, but then you would have ended up with 29x over 14x squared. You would kill an x, and you end up in the same place. So to be honest, you don't necessarily always need the LCD, but if you get the LCD, you have less reducing to do at the end.
Yes.
That's why we try to make it the LCD. Okay. This guy we already talked about, he's missing an M. He's missing an M plus 1. I highly recommend you do this.
Yes.
So then you get 3M minus 4M minus 4. So then I get negative M minus 4. And again, if you wanted to, you could pull a negative out, but there's really no reason. So I would take either one of these. You could take a negative out, but you should be able to see already nothing's going to go anywhere. You can stop here, you can go there. I don't care.
Yes.
How's that so far? Is that? So number 2 definitely has that weirdness going on. You can't add something top and bottom, so they're just missing each other. Aw. This has got the weirdness about one of the guys already has plenty, so we're not going to give him anything else. Because this guy, of course, has what?
X minus 3.
So he's already got everything. He's missing
And X.
an X.
Sorry, so I was looking at mine and I got m squared. And I was trying to figure out how you didn't get m squared.
Where did you get? Oh, on the bottom?
Yeah.
I just didn't multiply that out. That's all.
Oh, you just left it? Okay.
Yeah.
Okay.
In fact, not only am I letting you leave it so you got less shit to do, but you want to leave it so you can see at the end that nothing cancels. How do you see if something reduces? You factor. So why would you put this together and then later have to factor it again to see if anything, you see what I'm saying? So don't multiply the bottom out. Just leave it in its parts. All right, so what do I get on the top here? X minus 2 over, so this one should end up to be the easiest problem on this.
Yes.
Once you get over the fact that the second dude doesn't need anything. Yes?
Back to number 2, could I have left it at negative m subtract 4?
Yeah, that's why I circled both of these. You could stop here,
Okay.
or if you want one step further, that's fine also.
Okay, okay.
This is just kind of making sure that nothing cancels, which you could probably see right here, nothing would. Yeah. Okay. So here the first step is, so this is what?
X plus 3. And 2.
Good. Either order there. This is,
X plus 2 and 1.
that's awesome. There's only one way to factor 2. That kicks ass. Now, what's the first dude missing?
X plus 1.
He's missing that x plus 1. And what's the second dude missing? X plus 3.
So I get factoring, but I'm looking at it, they all look the same to me. Why are we, how do I know to factor that instead of, like for 4, we didn't really,
Yeah, we did.
I mean, we did, but
You
we didn't.
factor every bottom that can be factored. Period. Always. So can I factor what that was to begin with? No, it's just x minus 3. There's nothing to do there. Right? But this guy, they both have an x. Okay, I can do something. Does that make sense? If I can factor it, I do. Because then I can see what parts, and then I can compare what parts the other guy has and what parts the other guy's missing.
Okay.
Yeah. This would work if you gave this guy all of this and this guy all of this, but my God, that would really look disgusting. You have a lot of shit you didn't need. You'd have to factor the top at the end and kill a lot of shit, a lot more work than you really should have to do. Yeah.
And you need to factor is when the x's are not the like terms. Like there's an x squared plus 3x plus 2.
Yeah,
Then you have to
basically,
factor that because
I mean, see all the stuff that I didn't factor? It just had a single m. If there's just a single variable, how in the world could I break it up? Not easily anyway, right? Is this... Okay. All right. So here, what am I going to do to be careful?
Turn that positive and then negative right there.
So then I get
5x plus 5
5x plus 5
and negative 2x
minus 2x
minus 6.
minus 6. I love it. All over. And then you just, now it's cleanup time, right? So I guess
3x minus 1.
Minus 1.
minus 1 over x plus 1. X plus 2. X plus 2. Yes?
I thought since it was subtraction, you could just keep it as 5 and then parentheses x plus 1 and then just cancel them out and that's it.
No. So again, minus, what was there? 2. So you have this here, right? I mean, if you write this, division does not cancel subtraction. Division cannot cancel subtraction. Do you agree with that statement?
So we can't do it like that at all. It's not.
No, you can write this. You just can't do this.
Oh.
8 plus 5 divided by 8. Can you cancel the 8s? If you say yes, I'm very worried about you. You can't, because division cannot cancel addition. What is 8 plus 5 divided by 8? 13 over 8. I mean, that's what 8 plus 5 is. And can that reduce 13 over 8? Don't say mixed number. I'm not asking that. Can it reduce? No, because 8 and 13 share nothing. Even though 13 has an 8, when you write it as an addition, I don't care. Division can't do anything with that.
Is there a circumstance where you can write it like that and then cancel them out? Because
All right. Let me see. All right.
I probably did that before.
No. But if, let me show you somewhere this happens.
Like maybe not with subtraction.
You ready? You ready? You ready? Okay. Does this look a little familiar to anybody? This would be something you get like from Quadratic Formula, right? Just to go show an example. So let me, in case you're worried about this part, let me just make this, it doesn't matter what that part is. Let me just make it an X. In this case, I can kill the 2 as long as I kill it with both of these, because both of these are being divided by 2. That's really why, think about it. If I do this, wasn't this part also being divided by this? And if I do this, has he now escaped being divided by that? Magically, right? I like it. I don't know. Algebra class might be very different at Hogwarts, but here, can't do the freaky magic shit. I like it. Yeah, in fact, I never saw algebra class in any of this.
So
Yeah.
division can only cancel out multiplication?
Yeah.
Is that
Yes. Because division is the inverse function of multiplication. So that is one of its main jobs, is it kills multiplication wherever it sees it. I like it. So now, so watch this. Can I just kill the y's here? That is a y. Can I just kill the y's? No. Can I kill the y's here?
Yes.
Oh, hell yes, because division breaks the bond of multiplication, if you want to look at that. If you like chemistry at all. Or just division kills multiplication, so of course that works. This one? No, you can't just kill those. No. Okay. Yes?
Like what confuses people is that it's all under one bar. Like, is really like
What
X
does-
over Y plus Y.
What doesn't matter here is that there's one bar. What matters is there's 2 terms versus 1.
Yeah, so it's like cutting the bar, putting the addition sign, and having 2 fractions.
Yeah, so here you could write this as x over y plus y over y. You could do that all day long. Of course.
It's just multiplying, not add or subtract. That you can do that.
Yeah, you can only cancel things with division if they are being multiplied. Because division kills multiplication. It doesn't kill addition and subtraction. Yeah. Okay, maybe. Okay. Did we do all of them? Yes, okay. So any questions on that stuff there? Yes?
For the denominator, does it matter which order you write it?
No. Same thing as like the answer to a fraction factoring, not a fraction, but a factoring problem. If the answer I get is x plus 2, x minus 5, and you got x minus 5, x plus 2, we both got the same answer. Because 7 times 8 is the same thing as 8 times 7. So it's the same idea. It doesn't matter what order you put the parts in, as long as you got all the parts. I like it. Okay. All right. So I'm thinking a few things over in my head about some stuff. I think what I want to do, and I think you guys are going to be fine with it. Well, let's go over this a little bit, and then I'll think about it some more. 7.5. You might think the title is redundant. I don't know. like saying large jumbo or something. But no, I mean complex fractions. We've already seen an example of a complex fraction in a situation where I said you never have to do it to yourself, where I explained why division makes it flip. So complex fraction is a fraction that has fractions in it. That's a whole DiCaprio, fracception, whatever. So here's an example of what I'm talking about with variables. What you got, Jeff? Somebody see what's happening there? So yeah, the main fraction is here. On the top of this fraction is 1 over x minus 1 over y. And on the bottom is y minus x. This would be really easy if the top was just one fraction. Because then what can I do then? I can take that fraction times the reciprocal of that, right? So then that kind of motivates me as to what to do. I want to take the top, put it together. Make it a single fraction, because then I know how to divide fractions. How do I take the top and put them together? So I'm now just focusing on the top.
Okay.
Yeah.
Yeah. So.
Yeah.
There. Yeah, exactly. I love it. So what's this guy missing?
A
A
Y.
y. X. So now the bottom stays the same. And I haven't really changed the top. I didn't do something to the top. Do you guys get what I mean? Did it give the top anything it didn't have before? No, I really didn't. What did they multiply this guy by? 1 y over y. 1 x over... I didn't change the top. So I don't have to do anything to the bottom. Sometimes I got students that are like, I did something to the top. Don't the bottom have to change? No, we didn't change the top. We made the top look different. It's the same as it was. Well, what's it look like now?
1 Y.
Good?
Minus 1x
Good?
over xy.
And now you've got fraction divided by shit. How do you do that? Well, I do fraction times the reciprocal of this. Right? That divided by this is that times the reciprocal of this. Now that I made it one fraction divided by one fraction, I know how to do that shit. Even if you throw some variables in there, Jeff, I can still do that shit. I just flip the other dude. Yes, ma'am.
So you just cancel.
Now, exactly. Beautiful. What's the same on the top and bottom?
Y minus x.
And what's the answer?
1 over xy.
Beautiful. 1 over xy. Because where is the xy? On the freaking bottom. And what's on the top? 1. Make sure you put the answer where it is. You can't climb to the top.
That wasn't too bad.
Not really. Not really. Yes?
Will we have to deal with improper fractions and mixed numbers?
Not with variable expressions, thankfully.
Okay, good.
That would get unbelievably gross. So you're all like, how's that any different than what we've done? We haven't done unbelievably gross yet. I think I am gonna do this because I think you deserve this. I'm gonna make 7.5 extra credit. You understand what I just said?
Yep.
Okay. Maybe I won't do it anymore. You didn't get any reaction, so. You guys are like, it's about damn time.
I'm lost. I don't know how you got 1 over xy.
What
The
step?
last part.
What?
The very last part.
Well, all right, so you were cool with what I had written here, right?
Yeah, cool with that.
But isn't that there?
How did you get the y minus
Oh,
x?
so you're not cool with this part?
Well,
That's
No,
what I'm
I'm
asking.
not cool with it. Not cool with it.
Are you cool with this part?
yeah.
Yes.
Yes.
Don't say nobody is, because you're making a big
I am
assumption.
cool with the top part fraction doing that
All
part
right,
first.
so then you're
Yes,
cool
I
with this
got-
step totally.
Yes, got that.
All right. Now help me. Let me do a little side example. Do a little sidebar here. If I had 3/4 divided by 5, isn't that 3/4 divided by 5 like that, right?
Yes.
How do I do that? I do 3/4
multiplied by
times
Yeah.
1/5. So what is this? Isn't this y minus x over x? I just didn't want to write all that shit out, but I can. Isn't that how to write that?
Okay.
Right? So isn't that y minus x over xy times 1 over? Same way that we would do over there?
Okay.
I love it.
All right.
Beautiful. So that's what I meant. How do you divide a fraction by anything? You multiply by the reciprocal of that thing you're divided by. We know that's true.
And to like add on to that, like if it's a whole number, it's always going to be over a 1. So then you.
Yeah. So this is like a whole number
Yeah. Whole
because
number.
it's just one thing. There's no bottom part to it, so it's like over 1. So when you flip it, of course, it's 1 over that. So here, this would become 3/4 times 1/5, of course. The understood 1 suddenly shows up when I flip it. Yeah.
So the whole answer is y minus x over x times.
No. What's the answer? What do I do now?
1 over xy.
These cancel,
Right.
so I get 1 over xy. Yeah.
So whatever's left over is left.
Yeah, whoever survives
Bring it down.
is in the answer. And make sure he's in this place that he is. He can't climb to the top again, right? 1's on the top. XY, you're on the bottom. Yes? Yeah, sure. I'll do one more example. Since I'm making this extra credit. Let me do a slightly different example. Let's see. Yeah, perfect. Trying to get A there.
Sound like that?
Now, you can make problems that are more complicated than this, but the basic idea with these is make the top a single fraction, make the bottom a single fraction, because then I know what to do. I multiply by the reciprocal of the bottom. That's our motivation. So this is too much shit going on. There's a top fraction and a bottom. If I could just make them both one fraction, I can then multiply by the reciprocal of the bottom, make it a nice single line thing, not something inside of some holy shit. So I focus all my attention on each piece one at a time. And in this case, it's the same idea, really. What's the first dude missing?
A B.
Might get one? I guess so. He's missing a B. He's missing a A. I like it. So now you got, once you put those together, you'll have one fraction divided by one fraction, and you know what to do. So a lot of math is that. If you look back over your algebra experience, you learn something, and then the next section is like 2 steps, and then it becomes the thing you just learned. And then the next section is 2 steps, it becomes the thing you just learned. I mean, that's...
Yeah.
So, and why is that? Because I would need to figure out how to solve the basic idea, and then I start with weird shit, and I go, oh, the motivation is to make it look like this, because then I know what to do. So here, the motivation is to make this look like one fraction over one fraction, because then I know what to do. So here I get 5b minus 4a over ab over 2b plus 3a over ab. Now I'm trying desperately to skip this step here. If it's this divided by this, it's this times ab over 2b plus 3a. Don't distribute the shit, because you can see what happens. Yeah, the AB's canceled. They're dead. Why would they distribute anywhere? So then what's the answer? 5b minus 4a over 2b plus 3a. I love it. All right. Cool. All right. So that's extra credit, which means online people, it will be up there for you. I'm just going to make it worth 0 points, and then I'll look at it specifically, and if you get all the stuff or enough of it right, your homework average just goes up a little bit. Same thing for the textbook people. You can do it if you want to or not. And if you get enough of them right, I'll just take your homework average up a little bit, right? So if you do all the homework plus this, you'll have over 100% homework average. Or if you miss a few homeworks and you do this, it'll take the place of some of that. You're welcome. Okay. You're like, anytime you feel like doing that, John. And the reason I do that is because the next section is just a little more fundamentally practical than this is, to be honest. I need to focus on 7.6. Yes, we are doing a lot. So 7.6. 7.6, the really kick-ass thing about 7.6 is, I love some of your faces. This is a summer class. I have to remind you that. You signed up for it? It's all right. So the nice thing about 7.6 is the first step feels exactly like what we did in 7.4, which is give stuff what they're missing. That kicks so much ass. So let me do, whenever I say recall, that means it's from before this class. So you've had stuff like this before. In fact, I think we did one like this on the what do you call it? Warm-ups. I can't remember if it was in here or not. What you got, Jeff? All right, hold on. Sure. All right. So if I can make all the bottoms the same, I can then multiply both sides by that bottom, and there's no more bottoms. I've now killed all my fractions. Now, the minute students are shown how to kill fractions in an equation, you guys try to kill fractions everywhere. What is it about an equation that allows me to do what I just said? There's two sides, so I can balance it.
I was going to say, like, the 60 is the LCD.
60 is LCD, so what's the first student need?
5.
5.
Cancel 1.
And what's the student need?
12.
12. So let me just write some more steps than some of you guys might need, but oh, got it. Yeah, 24. So now if I multiply both sides by 60, what happens? This is where I feel so bad for some people. They'll kill this and then they'll somehow multiply by, no. This 60 kills these because it distributes. Is that cool? And in fact, you could just put it next to everybody if you want to make it more clear. How are we doing so far? Not good. Okay, let me try. What can I do to both sides of an equation? I can multiply by the same number. I can divide by the same number as long as it's not 0. I can add the same number. I can subtract the same number. I can square both sides. I can do a lot of shit. As long as I do it to both sides, there's a lot of stuff I could do. Is everybody cool with this step right here? This one.
So since all bottoms are 60, wouldn't you just, solve the top part? Like
Sort of. Sure, that's how it comes out, but what are you actually doing to get there is multiplying by 60 to kill them all. So what do I do to both sides of the equation to kill the 60? Now that they're all the same, I just have to do one thing. I just have to multiply by it. Right? In fact, what would you do to solve this problem? X over 4 equals 7. Why? Because then you can kill the 4, and that's why. Same damn thing. It just is in more places. But if I multiply by 60, it's going to kill all of them. If I multiply this side by 60, wouldn't I distribute the 60? So just put a 60 next to that one to make it quick. And then multiply this side by 60 because I did that side by 60. So now all the 60s cancel. That's the reason why I just did that. So hopefully that happens. Yes, sir.
So you put the 60 because pretty much you distribute the 5, and then you did the 12, you got the answers, and then you use the 60 to get...
Yeah, 60 was the LCD.
Right.
So I made everybody have that, and then I can just multiply by 60 and have all the fractions disappear. So what's left now? 5x. And just to make sure you understand, yes, what you just said is perfectly fine. But you need to understand why you get there, because you multiply by the bottoms, and that's why they're gone. Yes?
Are you always going to want to get rid of the fraction?
What would you think? If I had fractions in a problem and I was allowed to get rid of them, yes, right? And why? What is it about this problem that allows me to get rid of them? It's an equation. I'm allowed, and how do you kill fractions by multiplying, right? That's what kills the bottom. What allows me to do that is an equation. I can multiply both sides. If I don't have an equation, I can't just suddenly multiply it by shit. I've made it a totally different number now. Equation, two sides I can balance, beautiful, kick-ass. And now you just solve this like always. As 9x, subtract 9x, you get 15x, divide by 15. Nice. Once it's there, it's golden, right? Now, that was a problem you should come in knowing, right? Now let's look at the problems that we're going to look at. They're going to, of course, involve variable expressions on the bottom. Yes, ma'am?
Can you just show that last part real quick again? I'm so confused.
What? Wait. Okay. All right. Now, listen. I love you guys, but this problem, I am going to say this problem is easy. What did I do? I just quickly got to the answer because I know you guys can all do this. If you're sitting there just looking at it saying, how did he get there, instead of actually trying to solve it, you're not going to see how I got to where I got. Of course you're not. So what's the next step here?
Combine like terms.
Yes. 9x minus 1. Get your x's together. Minus 9x, minus 9x. I don't mean to scold you or anything, but on the really easy stuff, I'm going to maybe skip several steps. Because I'm like, you can always just kind of do it yourself later to double check. Or, you know, if you're like, I don't believe you, Jeff, you can do it real quick. But you can't just stare at the answer and just see where it came from. That would be, if you could, teach me, right? You can't, the steps are so convoluted, you can't kind of see how it gets there unless you do it. So yeah, now everybody's cool with that, right? All right. Yes?
I have a question for the multiply by 60. Can you also just put everything like in a bracket and then put multiply by 60?
From the beginning, right? For like the first step, right? Not even doing this shit, right? Not even making everybody 60. You just multiply by 60 off the bat, right? Yes, you can. But it doesn't help me worth shit with what we're about to do. That's why I show this when I teach this. I show this way. Because it's more useful for more complicated stuff. You always have to be thinking forward as a teacher, what's going to help the most later. Yes?
Oh, yes, it's a dumb question. I don't know. But, okay, so you got the 60s, right? You put them in the parentheses. I get that. But, I get you took the 60 from the bottom, but how would it cancel out?
No, I didn't take it. I multiplied both sides by 60.
Okay.
I can multiply both sides by 114.7. I can multiply by any damn thing I want to, but what's going to help me out the most is multiply by 60 because everything is divided by 60. Okay. So then they're going to cancel each other. I got no more bottoms, no more fractions. Kick ass. Yes?
So why didn't you do it to the numerator if whatever happens to the bottom has to be done to the top?
Cancel it out.
All right. You ready? I didn't do anything to the denominator. I did something to both sides of the equation. I did not multiply by 60 over 60. Bless you. That wouldn't accomplish anything. I multiplied both sides of this by 60. So that it's 60 over 1. Why is that legal? Because I did it to both sides of the equation. Doing 60 over 60 wouldn't do anything for me.
Yeah.
If I did 60 over 60, these would cancel and there'd still be a 60 there. It's like that problem would never end.
Yeah, I'm just asking like why you didn't do it to the top.
That's
like,
why.
I understand that. But.
That's why. Because I did something to both sides of the equation. I did the thing that would make the fractions go away.
I think where I wasn't seeing too was the step where 60 over 1 you cross multiply, but you're not showing that.
No.
Like,
Okay.
cancel out the
There's only one place where you cross multiply. Only one place. And that's when fraction equals fraction. Right. Then you can cross multiply because that's a shortcut of multiplying by the LCD. That's the one place that cross multiplication works. I did not cross multiply. All right. So the problem was here after I got an LCD, right? I can multiply by anything I want to. Everything currently is being divided by 60, so it makes sense to multiply by 60 because then those would kill each other. So if I multiply both sides by 60, this would distribute, so I just tell people, put 60 next to everything, because that's what it's going to do. Dead, right? It doesn't become 300x, because that's dead. 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 Yeah. And now you just write what survived, and then that's where that came from. Okay. I like it. Is that decent for everybody?
Yeah.
Okay. Yes.
So you can do what I kind of did was like skip that step of 60 over 1 time, times everything, and just realize that 60 is the denominator for each one, and they just all kind of cancel out.
Yes. As long as you understand why you're doing that, why that's okay. Yes. The mistake you might make is if you. There are mistakes you can make if you're not showing yourself that step. We'll do a problem. Well, let's see. If the problem would have been this, and very often students will say, well then I only need to make these, they're the only fractions in here. So I'm going to make this have 60, I'm going to make this have 60, and I'm going to multiply, and then I can just kill these, and then I get 5x plus 4x minus 1. No! How did you kill these? You multiplied by, oh shit, you forgot to multiply him by 60.
Yeah, you could do 4x minus 1 over 1.
Totally, yes.
And then make that into a fraction.
As long as you remember to do that, you'll be fine.
Show me where.
Yeah, but even if you did this,
And you had to find these combinations.
yes, okay. So, all right. So the bigger issue right now is I cannot possibly teach you and show you every way there is to do a problem. I will show you the way that I think will help you, especially for later problems that get more complicated. I'm going to focus on the way that will help us for that too. Because the more you understand that procedure here, the more you understand it in the place where you have to do that. There's no choice, right? I like it. There's more than one way to do any problem we do, obviously. And you can always ask me, is it okay if I do this? Is it okay if I do that? I like it. No problem. Kick ass. Okay. So here's the next level of this. Here's the stuff for this class. I have a problem like, let me take one right out of the homework. Where they get interesting. Here we go. So I kind of told you this is nice because the first steps are very much like the ones I did in Sem 4. In fact, you should kind of know what we're going to do here, and you can tell there's huge hints in these problems, right? Like this is the only piece I can factor, and of course it factors as this times this. So they have stuff in common already, right? So I factor this. So now what's he missing that everybody else has? X plus 2. What's he missing that everybody else has? X. So are we cool with that? I know the top had an X. I don't care about the top right now. I need to make all the bottoms the same. The bottom ain't got no X, just to show off my grammar. So I give it an X. Is this guy missing anything? So don't give him anything. He's not missing anything. All right. Now watch. Yes. See if you can handle multiple layers of shit. Everybody's got the same denominator. Everybody's got what denominator? X times x plus 2. So what am I going to multiply both sides by? X times x plus 2. Now real quick, can somebody tell me, the one difference between this problem and the one we just did is there's no way for the problem we just did to be undefined. Because it had numbers on the bottom, 5 and 60 and 12. Can this be undefined?
Yeah.
If x is 0 or Negative 2. So I know, right now I know x can't be 0 or negative 2. I just know that right now. If they show up in my answer, I got to throw them out. Very quickly. Have you guys ever witnessed this before? And as a student, it must be frustrating. I did all this work and math gave me this bogus answer. Screw you, math. And to be honest, no, it ain't math's fault. If x is 0, what did we just do? We just multiplied both sides by 0. We didn't know. We didn't know. So this is the only way math can communicate with us is to say x equals 0, but man, that makes it undefined. You better throw that shit out, right? It's like, oh, you did something weird, man. So it's not math's fault. So if I do this, what's going to happen? It's just going to cancel everywhere, right? So now what's left?
3 times x plus
Yeah, 3
x
plus 6, right?
x squared.
Plus x squared equals 4. Oh, that looks so much better. Still a little wonky, because what's the one part of this that tells me I've got to be careful how I solve this?
Yeah, you got factored.
Yeah, so I got to first get it equal to 0. Okay, so now I'm going to track 4. Let me get everything in the right order here. So I got x squared plus 3x plus 2 How do I solve that?
1 and 2.
Good. There's only one way to factor 2. That's awesome. X plus 2, x plus 1. And so you get x equals negative 1, negative 2. X can't be negative 2. So you throw that shit out. So x is negative 1. Can't be negative 2. Don't just not write negative 2. I need to see you write it and then exclude it. I like it, yes.
So why was it negative 2?
Because that makes it undefined. That cannot be the answer because it makes parts of the equation undefined.
Oh, okay.
No, it can't be negative 2. Or 0. But did we get 0 as a possible answer? No. Did we get negative 2 as a possible answer? Yes. Could that be an answer? No. It would make the bottom undefined. I really want you to get this. When we did this first step, what did this step accomplish? It destroyed the bottoms. It destroyed the place that had information about what makes it undefined. So math said, oh, here's the answers to this. The answers to this are these. Are they necessarily the same as the answers to this? No. This guy don't work here. It makes it undefined. When I did this step, I lost information about what makes it undefined. So the last step on these problems is just make sure that none of your answers freaks the equations out. If they do, throw them out.
So how would it not work?
I think it's because when you do it, I left it at x squared plus 2x instead of keeping it factored out to x times x.
But even then, you can see that x
Yeah.
can't be 0 and
Yeah.
x can't be negative 2. Yeah.
You gotta leave it that way to understand.
If you try to plug negative 2 in, what happens? You get over 0 in a few places. All you need is one place to go over 0 and the whole thing goes to shit.
So you just plug it in to check it.
Yeah. The last thing you do is just plug them in and just make sure they don't make any bottom 0. Does negative 1 make anybody 0 on the bottom? No. So he's fine. Does it mean that he works? Did I actually just check the answer? No, I didn't. I just made sure that that answer I got didn't freak anybody out. All right. I like it. So there's no guarantee it's the right answer, but at least that answer doesn't freak anybody out. Sure. If it was, yeah. What makes x plus 2 0? Negative 2. If there was an x minus 7, then I can't have a 7 as an answer because that would make it 0. So that's, yeah, I like it. Let's do one more and then we'll call it a day. What time is it? Yeah, that sounds good. Oh, let's steal another one from the book.
One last question. So there will always be one that is correct and one that's undefined?
No.
Or both of them be undefined?
Could be both good. Could be only one good. Could be none good.
So if none is good, would you just say the whole thing is undefined, the whole equation?
What's the answer then? If neither possible answer works, what's the solution? No solution.
Oh, yeah.
No, yeah.
Yeah. I like it. Don't put undefined because that doesn't make sense. The question is, what x's makes this equation work?
Okay.
That's the question. And if you go undefined, I'm like, if I make x undefined, it works? No. The answer then is no solution or no values work or whatever.
Yeah.
No solution is the standard thing we say. That should sound very familiar. Some of you guys might even know this symbol,
Yeah.
the empty set, right?
You accept that answer?
Yeah, totally.
Okay.
If you write your zeros this way, stop. Because this is a symbol in math that means empty set. It basically means no solution is what that means. It's really close to Slender Man, but it's all right. Nope. Let's do one more, and then we'll call it a day. Let's see what's got a little bit different thing going on. Oh, okay, let's do this one. This is not too bad. Here, you guys tried to get some distance with this. By the way, in the wild, in the real world, what I'm about to say wouldn't necessarily be true. But for us, this is pretty much going to factor as this times this.
Yes.
If you factor this incorrectly, you are going to make a problem that's, they're going to be missing like everything. And your problem's going to have like x to the fourth and shit. Don't do that to yourself. Oh, that's right. Oh, shoot. Oh, that's all right. Just look it up. Yes. Oh, could. Except for the fact.
For like, I'm trying back to the training class. Picking up right where we left off.
All right, guys. What's this first guy missing?
X plus 2, X plus 3. X minus 3.
Of course, he's got everybody.
I got it right.
Sweet. So then, if you multiply everything by this, yeah, so you get 3x plus 6. See how the 5x's cancel? Isn't that nice? And you get 3x equals 9. You add the 9 over, right? You get negative 9. X is 3.
No solution.
Beautiful. Can't be 3. No solution, or if you're not a fan of writing that much, you can just do like that. Let me ask you guys something real quick. I don't want to do this if most of you don't want to do this, but I was going to take you real quick down to the Tech Mall and show you where the Math Study Center is. If anybody wants to go with me, I'll take you. I'm not going to necessarily make everybody do that. You guys, does some of you guys know where the Tech Mall is? And inside is the math. If you go in the Tech Mall, the Math Study Center is over there.
Yeah.
Upstairs is the tutoring center, another place to get tutored. If you want to go with me, anybody want to go take a look real quick? Me and you.
Okay.
Aw.
Do you keep that one problem with this?
Yeah.
Analyze it.
I love. Well, that part's going to be neat.